Hello and welcome to our presentation for assignment 3. My name is Anchal and I will start the presentation followed by Jiakai, Echo, and Ray who will show the code implementation in MATLAB. So let's get started. So day by day, facial recognition is getting more public attention and attraction from big companies. Hence, the focus of our research will be facial recognition. In current events lately, specifically originating from the USA, many colored people are targeted and discriminated against. For example, the cases of George Floyd, Breonna Taylor, and Ahmaud Arbery. These were major turning points and highlighted the racism and discrimination that still exists in the world today. This was the main focus for us. This was the main motivation for us picking facial recognition and the focus point for our experiment. We want to be part of the solution and hope that some aspect of our research would help to provide a solution for these people. Through prior research and these events, we identified that the minority groups were clearly colored people and females. We believe that we could provide a real impacting solution to these people, specifically women. Facial recognition has covered various aspects of our real-life application. For instance, pictures from smartphones can be extracted to match your friend's profile to identify friends. Facial recognition can be used to help police for case solving as well. Moreover, facial recognition is an advanced classification problem, which we believe that consistent research will refresh our understanding towards the topic and benefit future prospects as well. Around the time of the worldwide Black Lives Matter movement, technology giant IBM stopped offering facial recognition software for surveillance and racial profiling in a way to combat racism. We believe that if a reputed technology firm is taking such a big step, smaller companies will follow in their footsteps and facial recognition and technology may be forced to go separate paths. So we would like to use our fresh knowledge and skills of image processing and design to impact these minorities clearly. I will now pass on to Jiakai, who will explain in more detail.
There are two technologies here, namely principal component analysis and speed up robust features. Principal component analysis is a statistical analysis method to master the main contradictions of things. It can analyze the main influencing factors from multi-things, reviews the essence of things, and simplify the complex problem. The purpose of principal component analysis is to project high dimensional data into lower dimensional space. Given m observations of n variables, n times m data matrix is formed. M is usually larger for complex things described by multi-variables. It is difficult for people to understand. So, can we grasp the main aspects of things to focus on analysis? If the main aspects of things are just reflected in several main variables, we only need to separate these variables and conduct detailed analysis. However, in general, it is not possible to find such key variables directly. At this time, we can use linear combinations of the original variables to represent the main aspects of things. PCA is such an analysis method. The basic idea of PCA face recognitions is to find the most representative future space from the face image. A single face image is mapped to this future space to get a set of coefficients of this future space. If the coefficients of two face image mapped to this future space are similar, It means that the two faces are the same people. In the aspect of speed up robust feature, SURF algorithm has 6 steps: constructing scale space, feature point location, main direction assignment of future points, generating future point descriptors, and future point matching. Hashing's matrix is a square matrix composed of the second particle derivatives of multivariate function, which describe the local curvature of the function. It was proposed by Ludwig Otto Hessian, a German mathematician in the 19th century. SURF compares each pixel pro processed by Hessian matrix with 26 points in the neighborhood of two-dimensional image space and scale space. Initially locates the key point and then filters out the weak key point and roam position key point to screen out the final stable future point. And then SURF algorithm takes a 44 rectangle block around the future point, and the direction of the rectangle area is along the main direction of the future point. A higher wavelet feature of 25 pixels in horizontal and vertical directions are counted in each subregion. The higher wavelet feature 4 directions after the horizontal directions value, after the vertical direction value, after the horizontal direction absolute value, and the vertical direction absolute value sum. SURF determines the matching degree by calculating the Euclidean distance between two future points. The shorter Euclidean distance is, the better matching degree of the two future points is. SURF also adds the judgment of Hessian matrix trace. If the positive and the negative signs of the two future points are the same, it means that the two future have the contrast change in same directions. If they are different, the contrast change direction of the two future points is opposite. Even if the Euclidean distance is zero, it is directly excluded. Next, Echo will explain the evaluation part.
Hi, I'm Haoxuan, and I'll evaluate the techniques that Jiakai mentioned. There are multiple algorithms of feature extraction, and we selected the speeded up robust features as our feature extraction algorithm. On the other hand, the accuracy of the result has been set as our evaluation standard, since the accuracy is intuitive among these standards. The speeded up robust features, as known as SURF technique, can implement easy calculation for faster convolutions by discretization and cropping. On the other hand, the image is transformed into coordinates using the multi-resolution pyramid technique to copy the original image with pyramidal Gaussian or Laplacian pyramid shape to obtain an image with the same size but with reduced bandwidth. This achieves a special blurring effect on the original image called scale space and ensures that the points of interest are scale invariant. The surf enables execution for different scales at the same time. Nevertheless, the surf is not stable for rotation. Also, the surf cannot work properly with illustration. Another algorithm that is chosen is PCA. The full name is Principal Component Analysis. With the implementation of PCA, the dataset is easier to use. Also, the PCA can reduce the computational cost of the algorithm. The calculation method is simple and easy to implement on the computer. In the process of PCA calculation, there is no need to set parameters artificially or interfere with the calculation according to any empirical model. The final result is only related to data and independent of users. In addition, the PCA can reduce the noise and enhance the readability of the dataset results. However, for the PCA algorithm, the eigenvalue decomposition has some limitations, such as the transformation matrix must be a square matrix, which is inconvenient. If the user has mastered some characteristics of the data, but they cannot intervene in the processing process by parameterization and other methods, it may not achieve the expected effect and it may have a low efficiency. Now I'll hand it to Ray, and he will demonstrate the code on MATLAB and evaluate the results.
Hello everyone, I'm Xiangyu Shang. This dataset is we used in our project. It contains 40 people, and each people have 10 different photos. For each photo, they have different physical details. For example, did they wear glass or not? Did they smell or not? And the size of each people is 92 times 112 pixels. Now let's go into show our code work. This image is called average image. It is known that now all the images are vectors, so we can find an average vector for each pixel and then combine them to create this image. We use accuracy here. We use accuracy as our evaluate method because accuracy is the most convenient and simple one. The whole project accuracy is 83%. Our aim is 100. The reason for we have a large error is the system may illegal some components with small contribute rate. It may cause a large error because these components have or may contain some very important information. In addition, we have used another method. We use one image which not exists in this dataset. We want to know, can our project find this mistake or not? The software still gives us the result. Of course, it is a wrong image. It's not surprised. This method need calculate the vector distance between the training data and the testing data. And then the system will choose the result which is the smallest one, and the system will give that one as the result. Okay, now let's go into show another code. This code is we use the method called surf. It is field. For the result, it can't find our training work. For the training process, yes, it can find the features for the training image. Also, it can find the features for the testing image. However, when the system compare with them, it only just finds a few features. Of course, for the result, it is failed. The reason why failed, we guess that the size of two images is different. One have a very high resolution retail and another one have the lower. So the lower one will miss a lot of information. Okay, that's all. Thanks for watching.